So today we will see the topic we will see how to convolute two sequences which is of one of them is of a very larger uh, length. Now the other name for this particular topic, that is convolution of long sequences, is linear filtering using DFT. Yes, we know the response of an LTI system for any arbitrary input is given by, that is y of n is given by what, x of n convolution h of n. And when we do this particular convolution, we always consider this x of n as a finite sequence. But in practical applications, it is never a finite sequence. Instead, it is much longer than the other, that is much longer than the impulse response. Now, when the sequence is very large, this particular convolution becomes very difficult using DFT. Why? Because when sequence is large, when x of n is large, what happens is that we have to get the entire sequence before convolution. This produces a delay in getting the output. So first reason is the entire sequence must be available before convolution. So this makes a long delay in getting the output. So I will write the delay in output. Okay. Now plus when you have a longer sequence, a large memory size is required. Large memory size is required, and the computation of DFT becomes very difficult. So in order to overcome this, what we do is we will section these larger sequences into smaller sequence, and that particular smaller sequence or the small section will be having the same size as that of your impulse response or h of n, or if whatever be the smaller sequence, that will be the length of one particular section. Okay. So in such cases, when your input sequence is very large, what we do is we go for sectioned convolutions. Now, in this particular technique, the longer sequence is sectioned into size of smaller sequence. So here, longer sequence is sectioned into the size of smaller sequence. Then the linear convolution of each section of longer sequence and the smaller sequence is performed, and the output sequence obtained from the convolution of all the sections are combined to get the overall output sequence. And this can be done in two methods. One method is overlap add method. And the second one is overlap save method. So I will explain once more. If you have a longer sequence x of n, then the convolution of x of n and h of n becomes very tedious. So in such cases, when x of n is very large, we go for section convolution, in which longer sequence is sectioned into the size of smaller sequences, and then that smaller sequence or h of n will be convoluted with the sections of that longer sequence x of n, and we will be getting the sectioned output and that sectioned output will be combined to get the overall output sequence. And this can be done in two methods, that is overlap add method and overlap save method. And we will see one by one. That is, first is overlap add method. We will see what is meant by overlap add method, or how sectioned convolutions are performed by overlap add method. Okay, now let's see this particular problem. Here h of n, that is the impulse response, is given as 1 1 1. So the length of this particular sequence is 3, and the input sequence x of n is equal to 3 minus 1 0 1 3 2 0 1 2 1. So let's see how output y of n is found out using section convolution. That is, here we are going to use overlap add method for section convolution. So as the first step, what you have to do is we have to find the length of input sequence, that is section sequence, and what is the total number of samples, what will be the total number of samples in the output sequence, that is y of. So when you go for section sequence, what you have to do is we have to find the length of smaller sequence. So here the smaller sequence h of n is having length 3. So smaller sequence, length of smaller sequence is denoted by m, and we know m is equal to 3. So what you have to do is we have to section these longer sequences as a block of 3 units. So we'll take length of smaller sequence, that is section sequence, as 3 again. Now, when you convolute this section to sequence with this impulse response, we will be getting an output, and that particular output will be having um, elements or the samples. Then the length of that particular y of n, that is section output y of n, will be equal to, as you normally find that output, number of elements in the output using the formula L plus M minus 1. So same way here also you can find. So this is 3 plus 3 minus 1. So here number of elements in the output we are considering it as 5. Now what we have to do in overlap add method is, first we have to write down sectioned inputs. So you have x1 of n first. Now you take x1 of n here. Now we know the length of the given sequence or the section sequence is 3. We have taken it as 3 since the length of smaller sequence is 3. And the output is having total number of elements 5, or it is number of elements in the output sequence, or I can say it is the block size. Okay. So what we'll do is to make actually we are finding out the linear convolution of these two sequences. This is linear filtering. So it is linear convolution. This is circular convolution. So when you find the output of linear convolution using circular convolution, what we have to do? We have to make the sequences, that is whatever whatever sequences you are convoluting, those sequences should have the length which is equal to the length of output sequence. That is how you convert or you find the output of linear convolution using circular convolution. So here again we are going for circular convolution. So what you have to do is we have to make the length of the sequences 5, which is the length of output sequence. So we know this length is 3, so you have to pad it with 2 zeros so that the length becomes 5. So, and that the zeros will be written as the 2 end elements, and the remaining 3 data points will be taken from the sequence. So let it be 3 minus 1. So you have 3 minus 1 0. So this is your first element. Now you go for second element. For writing the second element again, you have to pad it with 2 zeros. Then you write the remaining elements, that is 3 2 0. Same way you have x3 of n. So x3 of n again you have to pad it with 2 zeros. Write the remaining elements. Remaining elements is we have written 3 minus 1 0. Then this is, sorry, here it is 1 3 2. This is 1 3 2. Then you have 0 1 2. So 0 1 2. Then x4 of n is again whatever is remaining. You are provided with 1 only. So you have to pad it with 4 zeros. So these 2 zeros are the zeros we are adding or to get the total number of elements as 5. So now you have got x1 of n, x2 of n, x3. There are the sectioned sequences of that longer sequence. Now you write h of n. H of n is given as 1, 1, 1. So you have to make it 5 again. Total number of elements in the h of n sequence also is 5 here when you add it with 2 zeros. Now we have to find the individual inputs, that is y1 of n. y1 of n is x1 of n convolution h of n, or you can do h of n convolution x of n, x1 of n. Why? Because here x of n is remaining constant and we have 4 different inputs to find. So let's take h of n convolution. This is not a this is circular convolution. So let's do it now. So for finding y1 of n, what you have to do is when you perform circular convolution, you have to do matrix method. So in matrix method, first you have to write elements as first column. Then in the counterclockwise direction, you rotate it, 0 will come here, then 1, 1, 1, 0, then again 0, 0, 1, 1, 1, then 1, 0, 0, 1, 1, then 1 here, 1, 0, 0, 1. So now we have written the h of n sequence in matrix 4, that is a 4 by 4 matrix. Then you multiply it with x1 of n. So it is 3 minus 1, 0, 0, 0. So when you multiply these two, what you are getting is value of y1 of n. Now I'll write the value of y1 of n. y1 of n will be equal to 3, 2, 2, minus 1, 0. Now in the same pattern, you can find y2 of n. Now y2 of n will be equal to again h of n circular convolution x2 of n. So you have to write the same matrix 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, then 1, 1, 0, 0, 1 multiplied with x2 of n. Now what is your x2 of n? x2 of n is 13200. So I'll write it here. So it is 13200. Okay. Now when you multiply, you are getting answer as 14652. Now in the same way, you have to find what y3 of n and y4 of n. So yeah, I am writing the answer directly here. Same way you multiply. So when you multiply your answer for y3 of n, you will get it 0, 1, 3, 3, 2. And y4 of n, you will get it as 1, 1, 1, 0, 0. Okay. So now you have obtained individual output of that sectioned sequence, sectioned inputs. Okay. Now in the overlap add method, all these values. So I will write it here. So you have 3, 2, 2, minus 1, 0. So let's write here y1 of n is equal to 3, 2, 2, minus 1, 0. Y2 of n is equal to 1, 4, 6, 5, 2. Y4 of n is equal to, sorry, y3 of n is equal to 0, 1, 3, 3, 2. And y4 of n is equal to 1, 1, 1, 0, 0. 1, 1, 1, 0, 0. Okay. Now in overlap add method, what you have to do is you have to make this into blocks. So first we will make the block of y1 of n. So first that block will be having 5 elements. So let's make a block 1, 2, 3, 4, 5. And write the elements here 3, 2, 2, minus 1, 0. Now how many zeros you have added? You have added for zero padding that much units has to be overlapped with the second block. So here you have to, since we are added two zeros here, so two elements will be overlapped with the next sequence. That next sequence is 1, 4, 6, 5, 2. Same way we will write the third sequence. We have to overlap two units here. So 0, 1, 3, 3, 2. Here also overlap with two units. So this is 1, 1, 1, 0, 0. Now for getting y of n, what you have to do is y of n will be equal to, now whatever elements which is not overlapping, you write it as such. So 3, 2, 2 is coming. Then whatever elements it is getting overlap, you have to add it together. So this is added together. This is added together. So minus 1 plus 1, it is 0. 0 plus 4, it is 4. Then 6 is not getting overlap. So directly you can write it here. Then 5 plus 0 is 5. 2 plus 1 is 3. This is overlapping. So you add it. That is overlap add method. So whatever elements it is getting overlap, that you have to add. Then 3. 3 is not overlapping. Then 4, 3. So this is okay. 4, 3. Then 1. Okay. So this is the output y of n. Then this 0 you need not write, until 1 you have to write. So this is overlap add method. Now next is overlap same method. I have taken the same sequence. Let's see how this is convoluted section wise using overlap same method. Now here also we have to find the L, M, N values. L, you know, it is the length for smaller sequence. So here also L is equal to 3, M is equal to 3, L is equal to L plus M minus 1. So it is 5. Now we will start writing x1 of n. Now in overlap same method, x1 of n is written in the, it is not like an overlap add method. Now here, how many elements or how many zeros you have to pad to the sequence x1 of n, that means zeros you will be writing in the beginning of the sequence. So 0, 0 will come here. Then your length of the sequence should be 3. So 3 elements has to be taken. So we will take the first 3 elements, minus 1, 0. Now x2 of n, again you take the next 3 elements, that is 1, 3, 2, 1, 3, 2. And the remaining 2 elements must be taken from the previous sequence. So minus 1, 0 will come here. Then we will take x3 of n. So x3 of n, again whatever is remaining we have to write, that is 0, 1, 2. And the remaining 2 sequence must be taken from the previous sequence, that is x of n. So 3, 2, 0, 1, 2. Now x4 of n will be equal to what? Will be equal to, so a remaining 1 is there. So we have to pad it with 2 zeros. And remaining elements will be from the previous sequence, x3 of n. So this is 1, 2, 1, 0, 0, that is x4 of n. And we know h of n is equal to what? It is equal to 1, 1, 1, 0, 0. So we have made the length of input sequences and the impulse sequence equal to the length of output. So we are going to find the linear convolution value using circular convolution by this process. Now what you have to do? We have to find the y1 of n. So here y1 of n will be equal to the same procedure we have done in overlap add method. So 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 1. Okay. This must be multiplied with x1 of n So this is minus 1, 0, 3, 2, 2. Minus 1, 0, 3, 2, 2. Okay, so the sequence I have written is wrong. It is 0, 0, 3, minus 1, 0. Now the answer is equal to minus 1, 0, 3, 2, 2. Now y2 of n we will find out. Y2 of n will be equal to multiplying the same 4 by 4 matrix with minus 1, 0, 1, 3, 2. And the answer for this one is equal to 4, 1, 0, 4, 6. Okay. Now y3 of n is equal to, I am writing it directly. This is 6, 7, 5, 3, 3, and y4 of n is equal to 1, 3, 4, 3, 1. Okay, so we have done the matrix multiplication, that is, we have found out the values of individual convolution, y1 of n, y2 of n, y3 of n, and y4 of n. We have performed several convolution, but the answer we have obtained is that of a linear convolution. Okay, now what we have to do is we have to write blocks, write these values in the block form. Okay, so first we will make a block of 5 elements. 1, 2, 3, 4, 5. First one we'll write here minus 1, 0, 3, 2, 2. Now, here in the overlap add method, from the end of this block, we have overlapped the second block or the a block of second sequence. Now here what we have to do is we have to discard the number of elements which is equal to the zeros we have added to make the length equal to the output of convolution. So here you have padded the sequence with the 2 zeros. No. So we will discard the first 2 elements and then we overlap the other 3 elements with the block. So 1, 2, 3, 4, 5, it will come here. So second one is 4, 1, 0, 4, 6. Again, you have to leave first 2 elements. Then you have to overlap the remaining 3. So 1, 2, 3, 4, 5. So it is 6, 7, 5, 3, 3. Again, here also leave the first 2. Then you overlap with the other 3. So 1, 3, 4, 3, 1. Okay. So this is what we do in overlap. Save. Then how to write the sequence y of n. Now here y of n will be equal to, in overlap save method, whatever elements which are not coming in overlap, that element has to be discarded. So you have to see this is not overlapping with any of the elements that is discarded. Now you take the first block. In the first block, 3, 2, 2 is coming in, is overlapping with 4, 1, 0. So this is taken. So 3, 2, 2 is taken. Now you see the second sequence. Now the second sequence, you have to see below of this particular sequence. So when you see it, this is not getting overlapped. So this is discarded. So only these 3 is taken. So you write it here 0, 4, 6. Then in the next sequence, 6, 7 is not overlapping. Don't look above, you just look below. Below if there is any block or element which is getting overlapped with these elements. So this is discarded again. So 5, 3, 3 is written. From the third block, again 1, 3, we assume this is not getting overlap. So you can write 4, 3, 1. So here also the first 2 is discarded. Now this is the answer for finding. This answer has to be same with the answer we have obtained in overlap add method. So whichever method you perform, the answer we obtain is same, and it is the linear convolution value or linear filtering. where when you do linear filtering, this is the output that you have to obtain.